Hi class. Well, we're at a watershed in the course. We're done now with probability and statistics, and I will be emailing you your take-home test today. I'm also sending it through the U.S. mail. I'm being redundant here. I just want to make absolutely sure that everyone gets the test. So our new topic, and it's entirely new. We could have started the course with linear algebra in chapter 4. We're going to be studying for the next 4 lectures or so how to solve systems of linear equations. And your 5th quiz will concern what we cover in these 4 class meetings. Okay, so this shows by example what we mean by a system of linear equations. This is a 1-by-1 system. It has a constant and an unknown multiplied by a constant. 3 times x is 12. Easy to solve this equation. What number has the property that when you triple it you get 12? Well, of course it's 4. 12 divided by 3 is 4. So that's the solution to this system. Here's a 2-by-2 system, and these kinds of systems will be our focus this morning. So we have 2 equations and 2 unknowns. We want to find the numerical values for x and y that make both equations true simultaneously. That's what it means to solve a system. Here's a 3-by-3 system. Your 5th quiz is going to be concerned entirely with 3-by-3 systems of linear equations. And we're going to learn a technique that we can use to solve any system of linear equations, and it's an efficient technique. It's an algorithm that is very effective. You don't even have to have these numbers match, so you can have more equations than unknowns. There's a number of equations here. We could have 3 equations and 2 unknowns. We could have 2 equations and 3 unknowns. These numbers don't have to match, but you don't always get a single answer. So to this problem, the only answer, it's obvious, is x equal 4. Here also there's just one value for x and one value for y. And here also there's a value for x, a value for y, a value for z. But there are other cases that can occur. Okay, now we're going to focus on this one this morning. So let's write it to free up some space on the board. Write it up here at the top. Okay, now one approach that we can take, not terribly practical, but it's important nevertheless for visualization, for thinking about systems of linear equation, is the geometric approach, geometric or graphical approach. Okay, so the graph of each equation is a line. So find the graph of each equation. So you get 2 lines, and their point of intersection is the solution. So All right, so let's call this equation 1, a subscript 1. We'll call this equation 2. So we have an x-axis and a y-axis. This is the number 5. Now I'm going to go through this quickly because I only like my videos to be 15 or 20 minutes long. I'd take more time if we were still at AUN. Look at equation 1. Its graph is a line. We only need 2 points to determine a line. The way we get the 2 points is, the simplest way is assign y the value 0, and that says x will have to be 5. If y is 0, x is 5. That's this point. And if x is 0, three y is 5, so y is 5/3. That's this point. Okay, so whenever we won't be able to prove this, we just won't have time to discuss it. But any equation of this form has a graph that's a line. When you have x and a constant, y and a constant, we can supply the constant 1 here, and then just a simple constant. Any such equation has a graph that's a line. A line is determined by 2 points. Here are 2 points. Let's draw the line. So we can do the same thing with E2. If x is 0, y is -3. Let me write it here. Sorry for my handwriting. -3 here. So if x is 0, y is -3. That's this point. And if y is 0, -2x is -3, solve, so x is 3/2, minus over minus is plus. We get this point here. All right, so this is the graph of E1, this is the graph of E2. This common point, this point that belongs to both graphs, is the solution. If you were to do this on graph paper, you would see that that point is 2, 1. Those are the coordinates of this point. Okay, so the solution then is x equals 2, y equals 1. And you can also write this. The ordered pair x, y has coordinates 2, 1. You can verify this easily. Look at the first equation. If we replace x by 2 and y by 1, we get a true statement. 2 plus 3 times 1 is 5. And the same here. -4 plus 1 is -3. Okay. Now, let's continue discussing this. Okay. We're going to learn how to solve any system of linear equations, and it's an algorithm for solving any system of linear equations. called Gauss-Jordan elimination. We'll be using the acronym GJE because that's a long phrase to have to write over and over again. Okay, and the idea is to simplify linear systems by adding now this is the key thing, by adding a suitable multiple of one equation to another equation. A suitable multiple of one equation to another equation. And you may have to do this several times. Let's see how it goes. Now, let's apply the method to this simple problem here. You probably won't be very impressed because we don't really need a fancy method to solve a simple problem like this. But as we develop the topic, I hope I'll convince you that it is a very good method. Okay, so let's resolve the problem. So this is the second solution by Gauss-Jordan elimination, GJE. All right, I'm going to write the system again. Now, what I want to do is perform that step that I just described to you in such a way that we get rid of this term and we just have y equals something. We can't simply erase the term, that's a different problem. But what I want to do is double the top equation and add it to the bottom one. That's the key step. Double the top equation and add it, and then add to the bottom equation. So, now, this can be tricky, and until you get proficient in this method, I recommend that you do scratch work. So let's double each term in this equation. That would be 2x plus 6y equals 10. Add that to minus 2x plus y equals minus 3. Okay, so when we add these together, this term cancels this one. 2x minus 2x is 0. And 6y plus y is 7y. And 10 minus 3 is 7. Now this is the new bottom equation right here. All right, now here's how we write this operation. We double this equation, added it to this one, and what we get replaces this one. So 2 times I'll have to read this because you can't see it probably on your phone, cell phone or computer. 2 times E1 plus E2 replaces E2. So we have x plus 3y is 5 and 7y is 7. Okay, now what we've gained is the x term is missing, so we can easily solve this equation. You remember when we had an example of one equation and one unknown earlier, that was a trivial problem. I forget what it was, 3x equals 12 or something like that. This is just as simple. 7 times y is 7, so y has to be 1, right? So we can put a 1 there and figure out what x is. X plus 3 times 1 is 5. X plus 3 is 5, so x is 2. Okay, so y is 1, x is 2. That was our previous answer. Now, in general, what we want to try to do is, when we have a larger system, is keep performing these operations until we have what's called a triangular system. This pen seems to be dead. Let me give it a different color here. Doesn't that look like a triangle? This just has the unknown y. We can easily solve this equation, take the solution, put it in here, and figure out what x is. So we work from the bottom up. So when we are solving 3x3 systems, we're going to try to create an equivalent triangular system. So the bottom equation will just have z, the middle one will have y and z, the top one will have x, y, and z. And then we'll start at the bottom and work up and figure out the values of z, y, and x. All right, let's leave it at that. This is just introductory. And good luck on your test. Remember, do your own work. You have until a week from Thursday to submit your test. You can mail it back to me. There's going to be a stamped envelope, return envelope that you can use. We'll talk about how you can deliver the test back to me. There are other ways you can do it. But all right, well, I'll see you Thursday then.